Hi again, this is theorem number 4 on cyclic quadrilaterals. Here you'll see I've got a quadrilateral, a four-sided figure drawn where the four vertices of the quadrilateral are touching the circumference of the circle. You'll see I can move the points around the circle but not off the circle. So, definition of a cyclic quadrilateral is a four-sided figure where all four vertices are on the circumference of the circle. Now, it could be a rectangle or a trapezium, square, kite, rhombus, etc. Okay, what do we find? What's the interesting property about cyclic quadrilaterals is this. If I show you angles C and E, so you'll see C here is 98 degrees and E down here is 82 degrees. If you look at that, if you add those two angles together, they add up to 180 degrees. That is, they are supplementary, adds up to 180 degrees. If I look at the two opposite angles, B and D, they're the red angles here. In this case here, we can see angle B is 92 and angle D is 88. So the opposite angles add up to 180 degrees. Let's see what happens when I move point D here. You notice the size of angle D doesn't change because it's still sitting on this arc here, and the arc between B and C is not changing. That's related to theorem 1 and 3. But you'll notice the blue angles do change as I'm moving point D around. And so if I say, for instance, let's make a nice round one, so if C is 100 degrees, you'll notice angle E is 80 degrees. If I move B around, C and E will change again. So I can do something like, let's make angle E, say 100, and you'll see C is 80, but of course we can make them any size we want. It looks a bit like a kite to us. You can see C is 120 degrees and E is 60, both add up to 180. If I move point C around, you can see that D and E, angle D and angle B change, but they are still supplementary, that is, they add up to 180 degrees. There you can see they're both 90 degrees. If I say bring C right around to here, 104 and 76 add up to 180. So the theorem is the opposite angles in a cyclic quadrilateral are supplementary. That is, a quadrilateral whose all four points sit on a circle, then the opposite angles add up to 180 degrees. Let's turn to our booklet of notes. I've got two examples here. So in the first example here, I've got a cyclic quadrilateral because all four vertices are sitting on the circle. And if we look at angle A is 87, the angle opposite angle A is here at angle C. So those two angles must add up to 180 degrees. So if I first of all, in our notes, I'd like you to make sure this is in your notes. So first thing we'll say angle at C plus the angle at A is equal to 180 degrees. Then the next line we can say is this, that X plus 87 must equal 180, and therefore X will be equal to 93 degrees. I have a second example here. Once again, I've got another cyclic quadrilateral because points C, D, A and B are all on the circle, all four vertices. So therefore, here I've got angle B is 112, the angle up in this side of the cyclic quadrilateral at angle D, or the angle CDA, or even ADC, will be equal to 68 degrees because those two have to add 180. We're actually asked to find the angle ADE, so I start at A, go to D and out to E, so we're talking about the angle in here. If I know this angle here is 68, then I can work out this angle here because the line CE, it's an extension of the line CD, is a straight line. So those two angles in there must add up to 180. So in our notes, I'd like you to write this down, please. Angle CBA, that's this angle down here, plus angle CDA, which is up here, is 180. therefore angle CDA equals 68, so that's the angle up here where I've got the cursor at the moment. Then the next line you'll write is this. The angle ADE, the one we're asked to find, plus this angle here, CDA, is equal to 180. So we would write this. So angle ADE, the one we need to find, plus that angle, which we know now is 68, is equal to 180. So therefore, we take 68 away from both sides, we get ADE is equal to 112. In fact, that angle there is equal to that angle here. Later on we'll see another theorem which actually says the same thing. Thank you.